We were looking at the main components of the goods market model. We said the first component is total demand for goods or aggregate demand. And there we analyzed each of its components, C, I, G, and then we looked at how do we graph it given the assumptions that we're making. And here we graphed it in this graph with Z on the vertical axis and output on horizontal axis. So now we want to look at the second main component of our model, which is the 45-degree line. Now, in the YZ plane, now why are we looking at the YZ plane? Because when we plotted the demand schedule also, we made it in the YZ plane, where we had Z on the vertical axis and Y on horizontal axis. So in our YZ plane, like where we're working, the equation of the 45-degree line is Z is equal to Y. So the variable, which is, the equation of this line is such that the value of the variable on the vertical axis is equal to the value of the variable on the horizontal axis. Now, the equation of the 45-degree line in the YZ plane is Z is equal to Y, where Z is the variable on vertical axis, Y is the variable on horizontal axis. So if you compare this with the general equation of a straight line, Y is equal to mx plus C. So here we know Z is on the y-axis, Y is on the x-axis, and this essentially Z is equal to Y means Z is equal to 1 times Y plus 0. So from here we can identify this is an upward sloping line with slope 1. The slope is positive, it's upward sloping. So it's an upward sloping line with slope 1, which is like greater than 0, that goes through the origin because the vertical intercept is 0. So the 45-degree line is the second main component of our model. And in the YZ plane, in a graph with Y on horizontal axis and Z on vertical axis, the equation of this line is going to be Z is equal to Y. And when you compare it to the general equation of a straight line, you can identify this is an upward sloping line with slope 1 that goes through the origin because the vertical intercept is 0. Right, now let's look at an important property of the 45-degree line. Now, property of the 45-degree line is, so we know the equation of the line is Z is equal to Y. Z is what is being measured on the vertical axis, right? If we go back, so the equation of the 45-degree line in the YZ plane is Z is equal to Y. So from here it follows as the property of the 45-degree line is that at any point on this line, the value what is being measured on the horizontal axis Y is equal to the value of what is being measured in the vertical axis Z, right? The equation of the line is Z is equal to Y. So this means whatever is being measured in the vertical axis, Z in this case, is equal to the value whatever is being measured in the horizontal axis, Y in this case. Now, the reason I want to use the 45-degree line in this model is that Z and Y are not on the same axis. Z is on the vertical axis and Y is on the horizontal axis. So what we do is we use 45-degree line to take what's on x-axis, which is output here, to y-axis. 45-degree line essentially allows us to translate any horizontal distance into an equal vertical distance. Because remember, on this line, at any point, the value what is being measured on the horizontal axis is equal to the value being what is measured on the vertical axis. So you can use it to convert a horizontal distance into an equal vertical distance. If, for example, if I look at this point, at this point, I know output which is being measured as a horizontal distance y, which is AB in this case, right? I can use the 45-degree line to convert this horizontal distance into an equal vertical distance CD, because I know at this point the value of what is being measured on the horizontal axis AB is equal to the value what is being measured on the vertical axis CD. So the 45-degree line allows you to convert an horizontal distance AB into an equal vertical distance CD. Right? So we can convert what is being measured on horizontal axis into vertical axis. Similarly, at this point, this is what's being measured on the horizontal axis. We can use the 45-degree line to convert it into an equal vertical distance, because we know at any point in this line, the value what is being measured on the horizontal axis, this distance 1000, is equal to the value of what is being measured in the vertical axis, this distance 1000. So an important property of the 45-degree line is it allows you to convert any horizontal distance into an equal vertical distance. Now, why is this property important for us? We'll look at that in a bit when we look at how do we graphically represent equilibrium in the goods market.